For 60 years, every scientist who studied Jupiter agreed on one thing: the core. A dense, rocky ball sitting at the center. Maybe 10 times the mass of Earth. Compact. Bounded. Known. In 2017, that changed. Not because a new theory arrived. Not because someone ran a better simulation. Because a spacecraft dove close enough to feel it. And what it measured shattered the model entirely. Jupiter's core does not look the way we said it did. It does not look the way physics said it should. And that changes everything we thought we knew about how planets form. For most of modern astronomy, Jupiter's interior looked like this in every textbook. A thick outer atmosphere of hydrogen and helium, the clouds we can see. Below that, hydrogen compressed into a liquid. Deeper still, hydrogen crushed so hard it behaves like metal, conducting electricity, generating that enormous magnetic field. And at the very center, a solid core, rocky, dense. Around 10 Earth masses, maybe 15. Clean edges, predictable structure. Every model said this. Every simulation confirmed it. For 6 decades, no one seriously challenged the picture. It made sense. Gas giants form when a rocky core grows large enough to pull in surrounding gas. The core comes first. The atmosphere wraps around it. The core stays at the center, compact, defined, locked in place. We called it a compact core model, and we exported it everywhere. To Saturn, to Uranus, to Neptune, to every gas giant we found orbiting another star. The model wasn't just a guess about Jupiter. It was the foundation of how we understand large planets. Then Juno arrived, and the foundation cracked. Juno launched in 2011. It reached Jupiter in July 2016, after a 5-year, 2.8 billion kilometer journey. It carried no drill, no probe it could lower into the clouds, no instrument that could see through thousands of kilometers of gas. What it carried was a radio transmitter and a very precise clock. The method was indirect. As Juno swung close to Jupiter, closer than any spacecraft before it, some passes within 4,200 kilometers of the cloud tops, scientists on Earth tracked tiny variations in the radio signal. The way Jupiter's gravity pulled and shifted Juno's path. The way that pull changed as Juno moved from one hemisphere to the other. This is called Doppler gravity science. You cannot see the interior, you feel its weight. Like pressing your hand against a wall to sense what's on the other side. What they felt was wrong. The data, published in Nature in 2017, and refined through follow-up passes, pointed to something no model had predicted. Jupiter's core is not compact. It is not 10 Earth masses in a tight ball. It is dilute, spread out. Heavy elements, rock, iron, the material that was supposed to sit in a tight center, dissolved and smeared across a region spanning roughly 50% of Jupiter's total radius. The mass of that diffuse zone, somewhere between 300 and 500 Earth masses. Not a core, a dissolved core. A core that lost its edges. A core that faded into the planet that was supposed to surround it. The model required a boundary. Jupiter did not provide one. There is a particular kind of loss in science that doesn't get discussed much. Not the loss of a mission that fails, not the loss of funding. The loss of a model you spent your career building and defending and teaching to others and watching get used as the foundation for everything that came after it. The scientists who developed the compact core model in the 1960s and 70s were not wrong because they were careless. They were working with the best tools available. The physics was sound. The logic was clean. The model held together for half a century because nothing existed that could challenge it. Juno was built to challenge it. The team received the first gravity data in late 2016. The anomalies were immediate. The core was not where it was supposed to be. The mass was not concentrated the way it was supposed to be. Some of the researchers who had worked on Jupiter models for 30 years were still active. They read the same data. The mission Juno is still running, still measuring, still sending signals back across 2.8 billion kilometers. The dilute core remains unexplained. We know what it looks like now. We do not know how it got that way. The best current theory is that Jupiter was struck early, violently, by a protoplanet roughly 10 times the mass of Earth. The impact didn't destroy Jupiter. It disrupted it, shattered the compact core and mixed it inward, outward, upward, into the surrounding hydrogen. 4 billion years later, the core has never fully recovered. It has been dissolved this entire time, while we were modeling it as solid, while we were teaching it as known. Jupiter kept its real interior hidden from us for the entire history of human science. It didn't need to explain itself. It still doesn't. Jupiter's south magnetic pole is failing. Not slowly, not gradually. 20% weaker than it was 5 years ago. And nobody saw it coming. This isn't a measurement error. 3 independent spacecraft confirmed it. Juno's magnetometer recorded the drop during its latest pass. The field lines that should anchor deep into the planet are bending, twisting, collapsing inward like a structure losing its foundation. Here's why that matters. Jupiter's magnetic field is the largest structure in the solar system. It stretches 2 million miles into space, trapping radiation that would sterilize anything organic in hours. Earth's entire magnetosphere could fit inside one of Jupiter's field loops 20 times over, and now it's failing on the southern hemisphere. Scientists just figured out why, and the mechanism behind it suggests Jupiter's interior is nothing like what the textbooks describe. It's worse, and it's irreversible. Jupiter generates its magnetic field the same way Earth does. A spinning core of conductive material creates a dynamo. But Jupiter's core isn't iron, it's metallic hydrogen. Liquid hydrogen compressed under so much pressure, it stops being a gas and starts conducting electricity like metal. Nobody has ever seen metallic hydrogen. We can't make it in a lab. The pressures required are beyond anything we can replicate. It only exists in the crushing depths of gas giants. And Jupiter has an ocean of it, thousands of miles deep, spinning with the planet. But here's the problem. Juno's gravity measurements just revealed the metallic hydrogen layer isn't uniform. The southern hemisphere's layer is thinner, uneven, like the planet is lopsided on the inside. That asymmetry is why the south magnetic pole is collapsing. A thinner metallic hydrogen layer generates a weaker field, and as Jupiter spins, the imbalance is getting worse. The field lines are being twisted by the rotation, knotting themselves into unstable configurations. This isn't a temporary fluctuation. This is structural. While Jupiter's magnetic field collapses below, something impossible is happening above. At the North Pole, 8 cyclones have been locked in perfect geometric formation for over 6 years. Each storm 600 miles across, each one spinning at 400 miles per hour, and none of them drifting even slightly out of position. Gas giants aren't supposed to have stable geometry. Their atmospheres are chaos. Wind speeds vary by latitude. Pressure zones shift. Heat convection creates turbulence. There's no framework for 8 independent hurricanes to maintain spacing like they're welded in place. But they are. And new data suggests why. Deep below the storms in the pressure zones, Juno's microwave scans can penetrate. There are vertical columns of fast-moving gas, convection pillars rising from thousands of miles down, anchoring the surface storms like tent poles driven into bedrock. These pillars shouldn't be stable either, but they are. Because Jupiter's interior rotation isn't uniform. Different layers spin at different speeds, creating shear zones that lock the convection columns in place. It's a planetary scale machine with no off switch. The storms will keep spinning for thousands of years, maybe millions. And there's no atmospheric process that can dismantle them. Jupiter's North Pole is locked into a pattern it can't escape. The Great Red Spot has been shrinking for 200 years. Everyone knows that. But new high-resolution data reveals it's not fading, it's compressing, getting smaller in diameter but extending deeper into the atmosphere. Juno's latest pass measured the storm's depth at over 250 miles, 50 miles deeper than 5 years ago. Wind speeds at the edge just hit 430 miles per hour, faster than ever recorded. The storm is drilling itself into Jupiter. As it shrinks horizontally, it's gaining energy vertically, penetrating pressure zones that should shred any surface weather pattern. But the red spot isn't being destroyed. It's transforming into something more stable, more permanent. If this continues, the red spot won't disappear. It'll root so deep into Jupiter's atmosphere that no surface turbulence can dislodge it. A storm that's already lasted 300 years could become a permanent atmospheric feature, embedded in the planet like a scar. And there's no mechanism to stop it. The red spot isn't dying. It's evolving into something Jupiter can't get rid of. Europa's ice shell is cracking, not slowly, continuously. Webb telescope detected water vapor plumes erupting from surface fractures last year, which means Europa's subsurface ocean is under pressure. Enough pressure to force water through miles of ice and launch it into space. That ocean is 100 kilometers deep. No sunlight penetrates. No atmospheric oxygen exchange. Just liquid water under crushing pressure, heated by tidal flexing, sitting on a rocky seafloor in total darkness for 4 billion years. If anything is alive in Europa's ocean, it evolved in complete isolation. No evolutionary pressure from surface predators, no seasonal variation, no migration. Just an enclosed, pressurized abyss with no connection to anything else in the universe. We have no reference for what that kind of isolation produces. Earth's deep ocean life still connects to the surface through nutrient cycles and chemical exchange. Europa's ocean doesn't. It's a sealed system. If life exists there, it's operating on biological principles we've never encountered. Europa Clipper will fly through these geysers in 2030 and analyze the chemistry. If it detects organic molecules, we'll know something is happening down there. But we won't know what, or how, or whether it even resembles what we call life. Jupiter's gravity warps space-time within 400,000 miles. Anything that enters that radius experiences time dilation measurable by atomic clocks. 1 second on Io is not 1 second in deep space. Jupiter is bending reality around itself just by existing. But that gravity comes with cost. Io is being destroyed. Europa's ocean is locked in pressure. Ganymede's magnetic field is being twisted by Jupiter's collapsing south pole. Every moon in the Jovian system is being warped, heated, or irradiated by proximity to a planet that operates as a miniature physics laboratory. Jupiter formed first in our solar system. Its gravity determined where every other planet could exist. It shaped the asteroid belt by preventing planetesimals from coalescing. It deflects comets that would otherwise bombard Earth. But Jupiter isn't stable. Its magnetic field is asymmetric. Its interior is deformed. Its moons are being shredded. And all of it is irreversible. There's no corrective mechanism, no equilibrium state. Jupiter is a machine built with flawed parts, and it's been running on borrowed time for 4 billion years. Right now, 3 spacecraft are recording Jupiter's collapse in real time. Juno measures the magnetic field decay every orbit. Webb tracks atmospheric changes no visible light telescope can see. And in 2030, Europa Clipper will sample an ocean sealed off from the universe since the solar system formed. Jupiter isn't the king of planets, it's a warning. A demonstration of what happens when physics operates at scales we can't control and timeframes we can't escape. And it's happening right now, 40 minutes of light speed away.